Welcome to another of our lessons today. Today we'll be discussing naming of inorganic compounds. How we can name inorganic compounds without stress. It's very easy, quite easy, but let's just begin and see. But before we start, don't forget to like and subscribe to our channels for more information whenever we post a video. Alright, so let's begin. When naming a compound, the first thing you have to check is if the compound is made of two or more than two elements. Like in the case of this compound is made of two elements here, which are simply hydrogen and iodine. Then in this compound, you can see they are made of also two. The first one here is made of zinc and phosphorus. The next is made of iron and chlorine. The third is made of iron and iodine. Then sometimes it can be made of more than more than two elements. Sometimes it's made of three. Like in the case of this, you can see that this is made of three elements, which is potassium, um, nitrogen, and oxygen. So the method of naming is going to vary, will definitely vary. Okay, in the first, it's easy. Let's see if the compound is made of two elements. Then what you have to do, you name the first element, measure the name of the first element in full. This first element here is hydrogen. You name it in full. That's hydrogen. Then the other element, you have the name of the other element. The other element here is iodine, so we'll have it as IU. Then add IDE to the name, so the compound becomes hydrogen iodide. Hydrogen iodide. I said you mention the name of the first element in full. You have the name of the second element and you add IDE. This is hydrogen iodide. Now we can also try the same for this compound. This compound here is made of barium and sulfur. So you name the first element in full, so that is barium. So I said the other element, you have the name, that sulfur becomes the sulf. Then you add IDE to the name, so sulfur becomes sulfide. So the compound is called beryllium sulfide. Then you move to the next. Let's go to the next. Here we have three compounds here. The three compounds are here. You see the three metals here. They are all transition metals. Transition metals mean the oxidation states likely changing. If the oxidation state of the metal changes, you have to indicate the oxidation state, but if it doesn't change, it remains constant, so there's no need showing the oxidation number. Like in the case of zinc, the oxidation number of zinc is always +2, so there's no need to show it. I'll just say zinc, or I can say zinc. I can say zinc phosphorus. I said half the name, that becomes phos. Then add IDE, so this becomes phosphorus, zinc phosphide, sorry, or I can say zinc 2 because it's a transition metal. I can decide to say zinc 2 phosphide. The only reason I'm adding the phosphide is because I'm adding the zinc 2 is because zinc is a transition metal, but the oxidation number of zinc doesn't change in any condition. It will never change. Then in the case of the second example here, the first metal here is iron, so I will specify it in full, iron. But as a transition metal, the charge of iron changes here. To know the charge, I told you, you bring this here. The number of chlorine here tells the charge of iron, which is +2. So this becomes iron 2. Then the number of iron here, which is 1, you take it to the chlorine. So chlorine has a charge of -1. So the chlorine, no need for its charge. So the chlorine here, you write its name, half it. So it becomes chlor. Then you add IDE, becomes iron 2 chloride. Then in the case of the last compound here still is iron. So iron, sorry, it's still iron. So we can write the iron in full. That's iron. Iron. Then the charge of the ion here, you see it has changed from the +2 here. Now bring the 3 for iodine here, it becomes +3. You see the oxidation number varies because the oxidation number of ion can change between 2 and 3. We always state the oxidation number of ion in the compound. That's we use it for elements that the oxidation number always varies. That's why you will always show it in lead, iron, manganese, chromium, and so on. So let's come back to this element. So this is a compound. I said the other element here is iodine, and I said you have the name iode. Iodine becomes iode, then you add IDE, so it becomes ion 3 iodide. Then the next example here, the first element here is calcium. We do not alter this because the charge of calcium never changes, is always +2. We cannot show, or we should not show, the oxidation number of calcium, so we can write it in full. The name is calcium. Like we said, the name must be written in full for the first element, which is the metal, calcium. Then you have the name of the other, which is nitrogen here. It becomes nitr. Then you add IDE, so the compound becomes calcium nitride. Then in the case of the next here, this one has before we look at this, we would first of all look at a less technical one. Now let's see this is made of 3 different elements. Now in this case, the law is you will name from the left. You take the name of the element at the left, the number of atoms at the right. Now the element at the left is a metal. You name it in full and don't show its charge, because here the charge of potassium never changes, so it becomes potassium. Now from the left, I said you move to the right. The number of oxygen at the right is 2. When the number is 2, we call it di. When it's 3, it's tri. When it's 4, it's tetra. When it's 5, it's penta. When it's 6, it's hexa. When it's 7, it's hepta, and so on. So this becomes di. Oxygen, the oxygen becomes ozo. So that becomes di-ozo. That we've named the number of oxygen and the oxygen itself now. So we'll move to what is at the center. What is at the center here is nitrogen. Nitrogen becomes nitrates. So the element at the center, you have the name and you add ATE this time, not IDE. So when anytime you see the name ends in ATE or ITE, you know it has 3 different elements in it. So from here, you look at the oxidation number. The last thing that comes should be the oxidation number of the element that is at the center. It's easy to calculate here. To calculate it normal, we just say we don't know what is here. We know potassium to be group 1, that's +1, and oxygen to be 2-. There's no need even solving. The 2 of the oxygen here, use it to multiply the charge of the oxygen without its sign. Then you subtract the charge of potassium. That is 2 times 2 minus 1, which is the charge of the potassium. So 2 from the oxygen times the charge of the oxygen. 2 times 2 will give me 4. 4 minus the 1 of the potassium will give me 3. Will give us 3. So the charge here, write it in Roman numeral, which is 3. So the compound becomes potassium diazo nitrate 3. I guess that. Let's name this compound. Here I said the name of the element at the left should be written in full. That element is simply calcium, so we'll write it in full. Calcium, because the oxidation number of calcium does not change in any condition, so there's no need showing the charge of calcium there. Then I said go to the right. What is at the right is oxygen. Oxygen here is 3, and when it's 3, we'll call it a tri. So oxygen that becomes tri. Oxygen becomes ozo. Then the element at the middle is the next. What is at the middle here is nitrogen. So nitrogen, write the name nitrogen. So that's become 9. I said add ate to that name, which is nitrates. That's the name of the element of the compound, of the middle of the compound, sorry. So the last thing you want to do is to calculate the charge. Here there's a bracket here. The bracket means the charge of calcium is showing here, and the charge of the NO3 is showing at the number of calcium. So because there's an exchange which is showing as a bracket, we will use the number of oxygen, the total number of calcium atom in calculating this charge. So here the charge of oxygen is -2, so we'll say 3 for the oxygen times the charge of the oxygen, which is 2. There's no need for the sign, minus the total number of calcium ion here, which is 1, because there is exchange of ion here. What does it mean? It means the number of calcium here is the total charge of the nitrates. So we are saying 3 times 2 minus the charge of the NO3, which is also equals the number of the calcium that is here. So it becomes 6 minus 1, which is 5. So it becomes plus 5, which is V. So it becomes calcium triazo nitrate 5. Then in this example here, the same thing, name the first element in full is also calcium here, as we can see. At the right, we have oxygen. For oxygen, that's tetra, becomes tetraozo. At the center we have sulfur. Sulfur becomes sulfate. Then the charge of the sulfur in a bracket, in a bracket at the end. So oxygen carries 2 minus here. Number of calcium here, see there's no bracket, so the number of calcium here cannot be used. We cannot say 4 times 2, that's true, but we cannot say -1 calcium again, because there's no charge here, there's no exchange of charge, so we would not know the total charge of this XO4 to minus. So how do we know it? Is to use the charge of the calcium. So it becomes minus the charge of the calcium, which is 2. So anytime there is no exchange, meaning the compound is not carrying a bracket, like in the case of this CaSO4, what are we supposed to use to calculate? We use the charge of the calcium in the short form. But if there is a bracket showing exchange, like in the case of this Ca open bracket NO3 bracket 2, because there's exchange of charge here, we'll use the number of calcium that is here, because the number of calcium will show the charge of the anion. The number of the cation, sorry, will show the charge of the anion. So in this case, we will just simply say it is 4 times the 2 of the oxygen, which is 8, minus the charge of calcium. So it becomes 4 times 2, 8 minus 2, which is 6. That is Vi. So it becomes calcium tetraozo sulfate 6. Now let's move to a higher one. Here we have 3 elements. We will name that the one at the left first, followed by the other at the left. Now if that at the left has a changing oxidation number, then you have to specify the oxidation number. In this case, the oxidation number of calcium is always +2, so there's no need. Then you go to the next, which is hydrogen. Then you go to the right. Okay, let's follow it in the sequence. The first is the left, so it's going to be left, right, the center. So what is at the left first is calcium, so you write the calcium in full. Now if we remove this calcium, you will see it will still fall into the category of 3, just like this. I said here, when it's 3, you name what is at the left in full. So we are going to apply this again. So what is at the right now becomes hydrogen. We will also name this hydrogen in full. That becomes calcium hydrogen Now we'll go to the right. How many oxygen do we have at the right? We have 4. When it's 4, it's tetra. What has the 4? It's oxygen. Oxygen becomes ozo because it's at the right. Then what is at the center is phosphorus. I said you have it, becomes phosphate. And lastly, the charge of the phosphorus. Simple, the same way we did. That of oxygen is 2 minus, that of hydrogen is plus 1, that of calcium is plus 2. So it will give us the 2 of the oxygen times the 4, which is the number of oxygen atoms there. Then you subtract the 2 of the calcium and subtract the 1 of the hydrogen. That will give us the charge of the phosphorus without stress. So 2 times 4 should give us 8. 8 minus 2 minus 1 is minus 3. That should give us 5. So the oxidation number of phosphorus here is simply plus 5 in the Roman numeral. It becomes V. So we can call this compound calcium hydrogen. We can call it calcium hydrogen tetraozo phosphate 5 without stress. So the last is when it is made of 3 elements and one has a change in oxidation number, like in this case. Here, what is at the right, the left first of all is this, that is iron. And don't forget the oxidation number of iron changes. So because the oxidation number of iron changes, it means this comes here and this comes here. So iron is plus 3. So the charge of the iron here is plus 3 in bracket. Then you go to the right because it's made of 3 elements. I said the rule is left, right. What is at the right is oxygen. How many oxygen do we have? We have 7. 7 is hepta. That's hepta. Oxygen itself becomes ozo. Now at the middle we have chromium. And how many chromium do we have there? 2. When it's 2, it's di. Chromium becomes chromate because I said half the name and add ite, sorry, because it's 3. It becomes dichromate. Now the charge of the chromium also changes. The same thing we applied before. This, like we know, is plus 3. Then the chromium, we don't know. The oxygen is still minus. So I can say 7 times 2. 7 times 2 minus the charge of the ion, which is 3, should give me a total of 14. Total of 14 minus, sorry, there's a problem here. Because we've already exchanged the charges here. We're not supposed to use the charge of the ion here again because we've exchanged the charges here. Now look at it. When we did this, there was no exchange in charges. That is to say, when we exchange charges, then the charge we are normally supposed to use is the charge of the anion. So the charge of the anion here is 2. So it's supposed to be minus 2. So 7 times 2 minus 2, that should give us 14 minus 2, which is 12. So it means CrO2 has total of plus 12 charges. So if 2 have 12, how do we get that of 1? CrO will now be 12 over 2, which is equal to plus 6. So therefore it will be dichromate 6. I come again, it's like there's a little contradiction. I know some persons will be definitely confused here. I said if we have it as Fe2 open bracket Cr2O7 bracket 3. Now I said the name first is ion, then this charge here is that of the ion, so it becomes ion 3. Then the right hand side we have 7 oxygen, that's hepta ozo. Then at the center we have 2 chromium, which is dichromate. Now the charge of the chromium is the big deal here. Now I said oxygen is 2 minus. Here this 2 minus is for the chromium, that is to say Cr2O7 bracket 2 minus, then the oxygen is 2 minus, so 7 times the charge of the oxygen minus the net charge of the compound of the ion, the radical. That's 7 times 2 of the oxygen minus the 2 for the net charge, which is this. So the 2 comes from here, which is this. So the reason why I'm using this here is because there's an exchange of charge here. In the other compounds I did not use it because there was no exchange of charge. That's why you did not see any bracket. You cannot see any bracket here. Like all this, you cannot see any bracket here. I'm supposed yeah, this is just 2. So here there's no bracket, but here there is a bracket. So whenever there is a bracket, I will use the charge of the radical, which is the total anion. So here the charge of the anion will be the number of the metal that shows here. So here, if we do that, this will give me 6. So it becomes ion 2 heptaoxo dichromate 6. Then the last example here, okay, we've already done this, so I believe with this we have gotten to the end of this class. Please don't forget to like and subscribe, share. If you have any question, you can also put in the comment section so that we'll know how we can help. Thank you very much.